Hello. So let's try to understand what is the relationship between the roots of the polynomial. So we have seen last time what are the different kinds of polynomials that are there, right? And we have seen what are their roots. How do we identify their roots, like whether they have roots or they don't have roots? So we have seen that for a quadratic polynomial. So let's say that now we have a quadratic polynomial ax square plus bx plus c. So and the roots for this equation or this polynomial fx is alpha and beta. So these are the two roots of this quadratic polynomial. Okay. Now, when I say there are two roots, that means d is greater than 0, which is, so d is nothing but b square minus 4ac is greater than 0. So now what we are going to do is we are going to find the relationship between the polynomial and the equation. Okay. Now, if you see the sum of the polynomials alpha plus beta is nothing but minus b upon a. So minus b is the coefficient of x and a is the coefficient of x square. So the sum becomes minus b upon a. Similarly, the product of roots. So what is the product of the roots? Alpha into beta becomes c by a. So these two things we have to remember, and it's very important. Most of the questions that you see from this chapter will be based upon the sum and product of the roots. Okay. So minus b upon a and c upon a, that's what we have understood till now. Now we also want to understand if we have the sum and the product of the roots. Can we find the equation? Let's see how to do it. So let's say sum of the roots. So this is one uh, point that we have to understand. So this was point one. Now let's come to point number two, which is that we have sum and product of the roots. So like alpha plus beta is given to us. And we have also got alpha beta value, alpha into beta. So sum and product is aware, we are aware of, but we don't know what is the equation, right? What will be the equation? We don't know. So we want to understand based upon this sum and product, find the equation. Now, this is also simple. The polynomial will be k into x square minus of alpha plus beta into x plus alpha beta. So if you see here, I have used alpha plus beta in the coefficient of x. And if you remember here, alpha plus beta was minus b upon a. So we understand already that alpha plus beta, some of the zeros have a relationship with the coefficient of x. And that's what we have used here as well. Alpha plus beta we have put along with x. And similarly, alpha beta, which is the product, we use C, right? C is the constant, which is coming from here. So that's why for the constant part of the equation, we have used alpha beta. And this k that you see outside, because we have a here, right? In the bottom, in the denominator for both sum and product. So this thing, when we are going to bring it outside, it becomes k. So k can be anything. We don't need to worry about it. It will be some value of k, and this k can be found out based upon if we are given some value of x and the equation, we can find the value of k as well. But we don't need to worry about it. We can just understand that k is some factor which is a multiple of the whole equation. Okay. So this is important and this is also important. We'll see the questions based upon these two things now. Okay. I'll go ahead. So this is the first question that you see. If the roots of the polynomial this are reciprocal to each other. So what is the most important thing that you understand when you see a question? क्वेश्चन करना चालू नहीं करना है पहले। पहले हम समझेंगे क्वेश्चन में क्या पूछा गया है, क्या दिया गया है। सबसे पहले क्या दिया गया है ये नोट करेंगे। उसके बाद क्या पूछा गया है इस पे ध्यान देंगे। एंड देन वील फाइंड आउट द स्ट्रेटेजी कि हमें क्या स्ट्रेटेजी अप्लाई करके ये आंसर निकालना है। सो सबसे पहले हमने देखा यहाँ पे रूट्स की बात हो रही है। और ये quadratic polynomial है. So these things has to be taken care of very carefully, that we are talking about quadratic polynomial. We are talking about the roots of it. So if the roots of the polynomial this are reciprocal to each other, so what is the meaning of this? Roots are reciprocal of each other. So let's say one root is alpha. The reciprocal, what will be the reciprocal of alpha? So reciprocal of alpha is 1 upon alpha. So if you see very closely, we have alpha and 1 upon alpha as the roots of a particular equation. Now, uh, can you tell me one thing in particular which is very important coming out based upon these two roots that we have just now figured out? So if you have two numbers or two variables which are reciprocal of each other, then their product is, what is their product? Alpha into 1 upon alpha. So this and this gets cancelled. So product is 1. This is very important. And based upon this, we'll solve the whole question. Because if you see here, we have k in the last part. The constant part has the k. And that's how we have to find out the value of k here. Okay. Now for the product of the roots, which we have learned before, right? So the product alpha beta is product, right? And the formula that we know already is C upon A should be the product. Now, based upon this equation, what is what is C? C is minus K minus 2. Because in our scenario, it was AX square plus BX plus C. So therefore, the product was C upon A. Alpha beta was C upon A. But here, if you see in the equation, we have minus of K minus 2. So that's what I've taken as C. And what is A? A is the coefficient of x square. If you see here also, coefficient of x square is A. So I'll put A as 6 here. And since we know the product is 1, I'll equate it to 1. Now this is a simple equation that we can solve, right? So it becomes minus of k and plus of 2 becomes 6. So now what I'm going to do is I'm going to take this k here and 6 here. So k becomes 2 minus 6 because the signs of the equation gets changed, of the part of the equation gets changed, which move from one side of equals to another side. So that's why k becomes 2 minus 6, which is minus 4. And that's what we had to find. The question was find the value of k. So simple thing. The thing that was given in the question, the roots are reciprocal to each other, and based upon that, we have done this question. Okay. So let's move to next question. So we know, so okay, the question is if the zeros of the polynomial are in the ratio of 3 is to 4, then prove that 12a square equals to 49b. So that's what we are aware of now. So let's try to find out here what we can do. The zeros of the polynomial are in the ratio of 3 is to 4. So let's say the polynomials are 3x and, sorry, the zeros are 3x and 4x. Okay. Now, what we know is so this is all we can see from the question. We have a equation x square plus ax plus b, right? So based upon that, if I try to find out what is okay, so let's try to find out the sum first, because that's what we can do when we have the roots. Sum is minus b upon a, based upon our equation, which is ax square plus bx plus c, right? So based upon that, the sum is minus b upon a. So that means minus a upon 1, which is minus a for us. So this is clear to us. Sum is minus a. But let's see what is the product. Oh, and one more thing. The sum is minus a, but based upon this, we know sum is 3x plus 4x, right? Which is minus a. So 7x becomes minus a. Therefore, x is minus a by 7. So this we have found out from the first part. Now let's try to use the product part of the question of the zeros, and let's try to achieve. So one eye should always be on the question what we have to find out. We have to find out relationship between A and B. Okay. So what is the product here? Product is 3x into 4x. And from our equation which is written here, the product is C upon A. So this is product and sum is minus B by A. So that's what we have used here, right? So the product is 3x into 4x. Now based upon this equation, we will say the product is B only because there is no coefficient of x square. So that means it becomes 3 into 4 is 12, x square becomes B. So if you see clearly here, I mean, if you see very carefully, we have got 12 already. But we have to have the A square. But we have x square here. So we have to convert x into A somehow. So we know a relationship between x and A. So we can put it here, right? So 12 into minus A by 7 square becomes B. So what is minus square? Minus gets cancelled in the square, right? So it becomes 12 A square upon 7 into 7 is 49, but I'll push it to right hand side. So it will become 12 A square equals to 49B. Yeah, and that's what we had to find out, right? We had to prove 12A square equals to 49B. That's what we have calculated from here. So hope this is also clear. We have used sum and product of the zeros of the given equation. And based upon that, we have solved this question. Hope it's clear. I'll go to next question now. So if alpha and beta are the roots of a quadratic polynomial, px square plus qx plus 1 form a quadratic polynomial whose zeros are 2 upon alpha and 2 upon beta. So let's try to understand first. So we have px square plus qx plus 1. So this is the equation that we have now. And the roots are alpha and beta. So, uh, and the next part of the question says that we have to find another quadratic polynomial based upon the roots, which are 2 upon alpha and 2 upon beta. So, using the roots, if we don't know the roots, we can use sum and product of the roots to find the equation. But let's try to find out alpha and beta. I mean, because we have 2 upon alpha and 2 upon beta here, right? So based upon the given equation, which is this one, let's try to find the sum and product of the roots. So alpha plus beta becomes, which is sum, it becomes minus q by p. And alpha beta, which is product, becomes c upon it, that is 1 upon p here. Okay. So I hope this part is clear. You don't have any confusion in this one. Okay. Now we have to find another quadratic polynomial where zeros are 2 upon alpha and 2 upon beta. So this is the roots value that is given to us, and we have to find the equation. So based upon these roots that is given to us, let's find out what is sum, because that's what we have to do. We have to find out the sum and products, and then we can put in the equation. So sum becomes 2 upon alpha plus 2 upon beta. So, and if I take 2 comma, it is 1 upon alpha plus 1 upon beta. That becomes alpha plus beta upon alpha beta. I hope this is clear. You are not facing any issue here. So alpha plus beta we know is minus q upon p, 2 into minus q upon p upon alpha beta is 1 upon p. I'll put that as 1 as well. But this p gets cancelled. So sum becomes minus 2q. Hope this is clear till here. Now we'll also find the product here. 2 upon alpha into 2 upon beta. So that becomes 4 upon alpha beta. Now alpha beta is 1 upon p, which we have here. So let's put alpha beta as 1 upon p. So this becomes 4 upon 1 upon p. So that becomes 4p, right? Now, therefore, the equation that we had to find out was, so if we have roots, sum and product available, how do we find the equation? Find the equation using k into x square minus of alpha plus beta into x plus alpha into beta. Okay, so I'll put k as is. Sum is minus 2q, that's what we have calculated. So I'll put my x square minus of minus 2q into x plus this 4p is the product. So I'll put 4p here. So this becomes k into x square. So minus minus becomes plus 2qx plus 4p. So this is the equation that we had to find out. I hope this is also clear. So based upon the equation that was given to us and we had the roots as well, we found the sum and product of those roots. So because see, the point is if they have given us something in the question that is going to be used somewhere. So what I did using the roots of the equation, I can only do sum and product of the roots. So that's what I did. I found sum and product here. Now based upon this, two other roots are given, 2 upon alpha and 2 upon beta. I found 8 sum and products because I am going to use that to find the equation. And I have put the values of those sum and product in the equation. So I hope it's clear. I'll go to next one. So find the roots of the polynomial given as, let's just write it down. It's 8x square minus 2x minus 3. So this is the equation that is given to us. And we have to find the roots of this polynomial. Okay. So one of the important things that we have to understand, how do we find the roots of the polynomial? So when we have to find the roots, I think this you might have done before as well, like in the previous classes. So let's just try to do the equation. Try to solve this here now. So what we do is we multiply the constant and the coefficient of x square. That becomes 8 into 3 is 24. Now 24 has to be divided in such a way that we get answer as minus 2. So 24 factors has to be done, 2 factors has to be done such that their sum or difference becomes minus 2. So 8 3 is 24 and we know that 24 is 6 4 is also 24. So if I put 8x square minus 6x plus 4x minus 3, then in this case I can take 2 common from here. So it becomes 2 into 4x, sorry, 2x I can take common, 4x minus 3 here, plus 1 common from here, 4x minus 3 again. So it becomes 2x plus 1 and 4x minus 3. So if these are the roots of the equation, that means the equation is 0 at these 2 points. So if the equation is 0, so either this is 0 or this is 0. If this is 0, x becomes minus 1 by 2 or 3 by 4. So we have found the roots of the original equation that was given. Now let's try to find out the second part of the question. Hence, find the polynomial whose zeros are 2 less than the zeros of qx. So this was the qx that we had solved just now. We have found the roots of this equation. Now we have been told that we have to find the polynomial whose zeros are 2 less than the zeros of qx. Okay. So when I say 2 less, that means alpha becomes minus 1 by 2 minus 2. That becomes to the 4 minus 5 by 2. And beta becomes 3 by 4 minus 2. So that becomes 4 to the 8 minus 5 by 4. Okay. So this is what we have now. Now, based upon these two things, we have to find out the next polynomial. So what is alpha plus beta? Let's try to find out that first, because that's easier for us, right? So it becomes minus 5 by 2 plus, it will become minus only, minus 5 by 4. So if I take 4 as the denominator, becomes tan 15 minus 15 by 4. So this is sum. What is the product? Minus 5 by 2 into minus 5 by 4. So minus minus gets cancelled. It becomes 25 by 8. Okay. Now the second last part is very easy, right? We have to find the equation. The equation is very easy for us. We know equation is k into x square minus of alpha plus beta into x plus alpha beta. So this becomes k into x square. My alpha plus beta is minus 15 by 4. So I'll put as minus 15 by 4 into x plus alpha beta is 25 by 8. So I'll put it at as is. So minus minus becomes plus here, right? So it becomes k into x square plus 15x. Since we have 4 in the bottom, right, in the denominator, what I'll do, I'll take the denominator as, I'll take the denominator LCM. So it becomes, and I want to take it outside, right? It becomes 8x square plus 30x plus 25. And I have taken the denominator of 8 as outside. So I hope it's clear. We have found the equation, which was based upon the condition that was given in the question. So we had the polynomial, we find the roots of it. Then we found the other two roots based upon the condition given. And then we have found the equation for it using the sum and product. So I hope it's clear. I go to next question. So find the polynomial whose zeros are 2 and minus 7 by 5. So this is simple. You can do it very easily. So one is 2, the other root is minus 7 by 5. So let's find the sum first. What is sum? 2 plus minus 7 by 5. So if I see 5 to the 10, 10 minus 7 is 3, it becomes 3 by 5. What is the product? 2 into minus 7 by 5. So it becomes minus 14 by 5. Therefore, equation becomes k into x square minus 3 by 5x plus minus 14 by 5. Now, I'll take a denominator as 5 outside, k by 5. And since x square does not have any denominator, I'll have to multiply. Minus 5x square minus 3x. And this becomes minus 14 because plus minus becomes minus. And this is the equation that we are going to get in the answer. Okay. I hope it's clear as well. This question was very easy. I'll go to next one. So all of these questions that we have done till now, many of them has come in the CBSE exams, board exams. So I think if you are able to do these questions, if you are able to understand them, you can do the questions in the board as well. The main thing is that you have to practice more and more. Okay. So I'll go to the last part of the video where we are going to talk about the relationship between zeros of cubic and biquadratic polynomials. So let's say we have a cubic equation now. Let's see. Okay. Let's say we have 3x. Just a minute. Let's say we have 3x cube plus 4x square plus 7x plus 5. So this is the cubic equation that I have. Okay. Now I am going to the roots are alpha, beta, or let's say A, B, C. A, B, and C. So these are the roots of the cubic equation. Now I have to find the sum of these roots. That's the first thing. Okay. So sum is A plus B plus C. So which becomes, see, now one thing you have to remember. So in our scenario, which was ax square, I mean the question that we have done till now, that was quadratic. Sum was minus b by a and product was c by a. So here sum was alpha plus beta. They were taken alone, right? One at a time. And product was, we were taking it together. Okay. So similarly, what we have to do here is we will start with this one only. So it becomes minus 4 by 3 is the sum. But there is one change here. So till here it is same only. But there is one change now that we are talking about sum and product for quadratic because we have only two zeros. Now we have three zeros. So one more sum comes here that we are taking two zeros at a time. A into B plus B into C plus C into A. So we have to find out this also. Okay. So what we have done, we have used 4x square already. Now we are going to use 7. So, but please remember this, that we put a minus in the beginning only in alternate terms. So even though there was no minus given here, right? We added this minus as a part of our solution. As a part of the formula that we are doing. Okay. I'll just remove this so as to remove the confusion. So some of the roots are taken two at a time. So let's say this is S2 and this was S1. It becomes 7 upon 3. Okay. I'm using this coefficient of x now. Now for the last part, S3, which is sum of the roots taken 3 at a time. That means A into B into C becomes 5 upon 3. But this will be negative because negative has to be alternate, right? So I hope this is clear. Uh, okay, so let's talk about biquadratic now. So this is the last part now. Uh, let's say we have equation 4, or let's say 7 x to power 4 minus 5 x to power 3 minus 6 x square plus 4 x plus 4x minus 3. So similarly, I have to find out the sum of the roots. So sum here is, I mean the zeros are A, B, C and D. So these are the zeros here. So when I say sum of zeros taken one at a time, it becomes A plus B plus C plus D. That becomes, again, I'll start from here only. I'll put negative. So it is minus of minus 5 by 7, which becomes 5 by 7. So this negative that I have put, because we have to use the negative alternately when we are finding a sum. So here, that's why I have used it. Okay. I'll remove it. I'll remove the arrow for now. Now the second thing is sum of the roots taken two at a time. So that becomes A into B plus B into C plus C into D plus D into A. So this becomes minus 6 upon 7. So if you see here, I have not put additional negative. Minus 6 is because there was this negative already in the equation. And that's what I have put here. Okay. So sum of roots taken two at a time becomes minus 6 upon 7. Sum of roots taken 3 at a time also is possible now. So it's A, B, C plus B, C, D plus C, D, A. Okay, these three terms will come now. So it will be 4. We'll use 4 here and 4 upon 7. But since we have to use negative alternately, I have to put one negative extra. And there was no negative coming here, right, from this part. But I have put one more negative from our formula perspective. And the last part is we are taking sum of all four zeros together. So S4 is A, B, C, D taken all of them together. It becomes minus 3 by 7. And I have not put any negative here because we have already put here. We are putting in alternate sums. So I put the negative extra in S1. I have put a negative extra in S3, right? But in S2 and S4, I have not put extra. So this was already there. this particular negative, right? And even in S4, the negative was already there in the coefficient, so I just used it. So I hope this is clear. Ah, okay. See you. Thank you. See you in the next lecture. Thank you.